to solve another Leetcode problem. 1039 minimum score triangulation of polygon. So we are given a polygon and we want to split the polygon into several parts, and we want to calculate the minimum score. And the minimum score is defined by the product of all the value of the vertices. So for example, we can split into two parts. So one type is we can split from 5 to 7, so the result is going to be 245. Another split is we can split 3 and 4. So 3 times 4 times 5 plus 3 times 4 times 7 is going to be 144, and this is going to be the minimum solution. But how can we solve the problem? So the problem is that if we have a polygon like this, normally we can split it into different parts. Yeah, but we need to fix one position. So for example, we need to take two vertices. So for example, this is AB, and if we take AB, and then AB gonna be fixed, and we're gonna enumerate other vertices. So for example, C, if we follow C, so we're gonna split it into two parts, left part and the right part. So the left part becomes, so for example, this is D, becomes ADC, and the right part becomes BEFC. So for ACB, we can calculate a product. Maybe this is 6, and maybe this area is 8, or maybe this is 4, and we just need to plus all of them. Maybe this is 4 plus 6 plus 18, and this is just one of the splittings. And if this is not the smallest, we're gonna try to enumerate another one. So for example, if this is not C, we're gonna enumerate another one. Maybe this is AB still, and we're gonna enumerate another one. Maybe this is this is C gonna be here, and then we check this area, and this area. But finally, we're gonna check the minimum of all the possible solutions. So this is a range DP problem. Yeah. So for the array, we're gonna prepare a range. So this is all the values from I to J. And while we are going to solve the problem, because it is a triangle, so we're gonna fix this I to J, and we're gonna enumerate all the values in between I to J, but not include I to J, because it must be a triangle. So this is gonna be K. Yeah. So the final result gonna be the values of I times the values of J times the values of K, and plus plus the range areas from I to K and K to J, plus those two areas. So this is going to be the final solution. And the DP or DFS I to J, and means the minimum split of all the possible solutions. So this is our interval DP. So the interval is I to J. If we were to calculate the DP I to J, we have to split it and let it become smaller, and then we're gonna solve it the smaller problem. And for the smaller problem, if it cannot become a triangle, maybe it just becomes on one line. There's no triangle. It just becomes one line. Yeah, it means so for I it is I, and J gonna become I plus 1. If it is this condition, it means it's edge case. So we're gonna return a 0 because it becomes a line. If it is a line, there's no product, because the product must be 3 dots. It must be a triangle. Yeah. Now let's go to the code editor to solve the problem. First of all, we're gonna try to solve it by using DFS plus memorization. So for the DFS, we're gonna define DFS function. So inside it's gonna be I to J. So this means the minimum result from the range I to J. The minimum result is the return, so the smallest possible total score that we can achieve with some triangulation of the polygon. So the condition is if I plus 1 equal to J. So this means the condition is like So this means the condition is I to J, and J is I plus 1, it becomes a line. Basically, that is not possible. So if I plus 1 equal to J, So we're gonna return 0 because there's nothing to plus, nothing to plus. We just put it 0. And then we're gonna prepare a result, and we're gonna check the smallest value. So the result gonna be set to infinity, and then we're gonna check enumerate the k. We're gonna enumerate another vertices between I to z. So for k in range, here gonna be I plus 1 because it must be between I to z but not include. Yeah. So I plus 1 to z. Yeah, so for k in range, we're gonna check the smallest. So the result gonna be the minimum of the result, and because of this k split it into two parts, so it's gonna become DFS from I to k, and plus another part it is DFS from k to z. And also we need to plus the product of the triangle because we already found one triangle, we must plus it. So values I times values j and times values k. So this is going to be our triangle. Yeah, and the final result going to be this result. So for the DFS I to z, and it's going to be the result. Now we need to call this function. It's going to be DFS 0 to length of the values minus 1. Yeah, this means just for this line, it's going to become this I to this z, and we're going to enumerate the k and check all the possible results, and the result is going to be the minimum of all the possible results. Yeah, and this I plus 1 to z, it means just the values between this I to z, but not include I and not include z, just the value between. And in this way, we're going to enumerate all the possible values, and the time complexity is I times z times k. So it is 50 times 50 times 50 n cubic. It should be okay. Now let me run it to check if it works. Now as you can see, it works. Now let me submit it to check if it can pass. And by the way, the space complexity is n squared because we only used I and j as our hash table because we used a cache. Yeah, as you can see, it's pretty fast. It is okay. Now let's try to optimize it. So this is definitely DFS plus memorization. Now we're going to optimize this solution to a real DP. So for the real DP, we need to check this I and to j, how the function is translated from this I to j. If we want to get the value of function fi to j, so this I is coming from where? As you can see, this is I, and this I is the position is here, k. So there is one transition. The transition is from k to I. So it means if we want to get the value of fi, definitely we want to get the value of fk first, because it is at the first position. This is k and this is I. And this means k is bigger. Yeah, because this is I. K is in between I to j. K is bigger than I. So how did we get the value of I? We get it from a bigger value, not a smaller value. If we get a bigger value to get this I, this means we're gonna use the bottom up. Yeah, this means for I, for the iteration of the I, it's gonna be from the bigger value to the smaller value. And let's talk about it. This is j. J is coming. Let's check the second position. Is coming from this k, as you can see from here. Yeah, j is coming from this k, and k is bigger than j. This means j is coming from a smaller value. If it is coming from a smaller value, this means j is coming. This means for the iteration of j, it's gonna be from the smaller value to the bigger value. So basically, if we draw it, it would be basically like this. This is a rectangle, and this is our areas we are calculating in these areas. This means for I, it's going to become a bigger value to a smaller value. This is the row. Yeah, this is n minus 1 to 0. This is for row. And for the bottom, it's going to become the smaller value to the bigger value. This is for the bottom. And finally, we're going to fill in all the values in the top right right triangle areas. And finally, this is our solution. It is f0 to n minus 1. It's here. Yeah. Now let's just make a comment of the DFS and try to write the real dt. Yeah. So I'm going to prepare a variable n. It's going to be the length of the values, and I'm going to prepare a table of dt. So it's going to be 0 times n. So for r in range, so r is just for rows, and you can also use underline. It is the same, but I prefer to use r. So for r in range with n. So this is our dp table, and then we're gonna enumerate I first. So as I explained earlier, I gonna become from bigger value to smaller value. So, but at least we should have a triangle. It means for this I, at least we should keep 3 values, otherwise there will be no triangle. So it's gonna be n minus 3. Yeah, so this means it's gonna have n minus 3, n minus 2, and n minus 1. It's gonna have 3 values, because normally this I is smaller and j is bigger. So it's gonna be minus 1 and minus 1. And then we're going to enumerate this j. So for this j need to keep it to n minus 1 basically. If j were to keep it to n minus 1, it means there is a k equal to n minus 2. But how can j make it to n minus 1? It is I plus 2. This is n minus 2, I plus 2, n minus 3 plus 2, it is n minus 1. And this is exactly what we need, because we need to let ijk become at least a triangle. Yeah. Now, from I plus 2 to n, so this is going to be the nj. Now we're going to prepare a result. Similarly, it's going to be like here. Let's just copy the code. Now we're gonna use a for loop. Yeah, it's gonna be the same. Let me just copy the formula from here. Yeah. So for k in range, this is gonna be I plus 1 to j, because k is starting from I plus 1, but j is not included, so this is okay. And then we're going to check the result. So the result is going to be the minimum of the dp. Yeah, so let's change this one, those two to dp. It's going to be f I to k plus f k to j, and plus the values of ijk. Yeah, this is just a product. And this is going to be the minimum result, because we enumerate all the possible cases. And for the subproblem, we just already recorded this kind of a subproblem, because as I explained earlier, and this I gonna be smaller than k, because I is smaller than k, and k is smaller than j. So this is why we prepared an iteration from the bottom up. Yeah. Now we're gonna return the final result. So it's going to be f0 to n minus 1. Yeah. Now let me just run it to check if it works. There's something wrong. There's only 0 inside. This means something wrong with my tabulation. Let me just have a check. Yeah, let me just have a check what is inside the f. It is always to be 0. I didn't prepare anything inside. Let me just check why. I think it's because because I didn't I forgot to update the value. So from here, our result have already checked. So this is going to be the minimum of the result. So now we're going to update the result. It's going to be fi to j. It's going to be the minimum value, and it's going to be this result. Now I think it's going to be okay. Now let's just check it. Now as you can see, in our rectangle, it is exactly like what we expected. Let me make it like this. Maybe, yeah, we just Yeah, let me just copy it, and you can see, and this is gonna become a top right triangle. Yeah, let me copy it here. Yeah, let's just check what is this. Yeah, because this is gonna be a triangle, you're gonna understand it like a tabulation. So now I think you can understand it clearly, and because this is exactly like what we expected. As you can see from here, this line, it is always to be 0, and this line, it is always to be 0. This is what we expected, and then we're gonna check the value until we get it here, and this 13 gonna be the smallest. Yeah, and this is what we expected from that 13. Maybe there's this testing case, it is 13. Yeah. Now let me delete these areas and try to submit it to check if it works. Let me delete this printf to check the speed as well. Yeah, so normally this is the best solution because the tabulation gonna always be the best solution for solving DP. But if this is difficult to think about, normally we're gonna use the DFS plus memorization to solve the problem. Thank you for watching. See you next time.